Welcome to Erudition's PAT walkthrough videos. This is our third video on angle ranking strategy. We are discussing all of the different angles you'll find on your PAT. You can separate the types of angles into 4 different categories. Very acute, sharp angles, large acute angles, near right angles, and very obtuse angles. In our last video, we went over how to visualize and compare very acute angles and larger acute angles. So in this video, we're going to take a closer look at near right angles and very obtuse angles. These two groups include all of the largest angles that you'll see on your DAT. And these angles can be pretty tricky because, one, there's a very wide range of sizes and therefore shapes to the angles. And two, there's no nice sharp tip to focus on, as there was with the smaller angles. And three, perhaps most importantly, these angles are so big that a difference of only a few degrees can be really difficult to detect. So let's start by looking at some near right angles. As you can probably guess, our strategy for analyzing near right angles is to compare them in your head to an actual right angle. But when is an acute angle large enough or an obtuse angle small enough to compare to a right angle? In the last video, we discussed large acute angles and showed that even angles around this size, it may indeed be helpful to compare them to right angles and see how open they are. So then, as angles get bigger, it becomes more and more helpful to compare them to a right angle. So essentially, angles around this size, and even a little bit smaller, if you feel a little stuck or it feels like it's going to be helpful, you'll maybe want to compare to a right angle. But once it gets around this size, we would definitely recommend comparing with a right angle. That's probably going to be your best bet. So, just like in the last video, to do a comparison with a right angle, you'll want to align the bottom leg of your imaginary right angle to the bottom leg of the angles in your problem. All 4 of these angles are oriented in the same direction and positioned similarly, so where to put your right angles is fairly intuitive. You can also tilt your head slightly to the right to better view these angles. Because these angles are acute, you'll of course want to look at how much smaller they are than the right angle. Notice how much this helps you visualize the difference between the angles compared to just looking at their peaks. Likewise, for more obtuse angles, it's often just as helpful to compare these to right angles as well. In the case of obtuse angles, you'll want to see how much larger they are than a right angle. And right off the bat, again, this is much more effective than looking at the center of the angles. Now, what about very obtuse angles? There are sometimes cases where it's better to compare them to a straight line. With angles like these, I actually like to have a little bit of fun with it, or as much fun as possible with angle ranking problems, and I'll picture them as reclining chairs or beach chairs. I try and visualize which chair or which angle is the most reclined. Again, much better than just looking at the centers. Those are kind of the basics of near right and very obtuse angles. So let's look at some example problems. In a problem like this, it's going to be pretty challenging to compare just by looking at the peaks of the angles. But fortunately for us, they are all near right angles. So we can try to better approximate their size by seeing how they compare to a real right angle. With angles like this that have a long arm and a short arm, it's often the best to align the leg of the right angle with the longer leg of the angle in question, like this. So, right off the bat, it's probably easiest to see that angle 2 and angle 4 are our smallest angles. We can see that both are not quite square inside, just a little bit smaller than a right angle. Just from learning this, we can actually eliminate choice B, because it does not list these 2 angles as its smallest 2 angles. If we look closer, we can see angle 2 is actually smaller, just a little bit more acute. And that means we can also eliminate choice D because it lists angle 4 as the smallest. Looking at the other 2 angles, we can see that angle 3 is very close to a right angle. And angle 1 is actually quite a bit bigger, which makes angle 1 the largest angle, and choice A our correct answer. In this example, notice how all the angles have an arm that's positioned vertically. and the other arm kind of hangs down. So we'll want to arrange our imaginary right angles like this, and then try and visualize how far the arms are hanging down. In this problem, it's probably easiest to see that angle 1's arm drops down the farthest, so that makes it the largest angle, and so we can eliminate choice D. The other answer choices still have 3 distinct angles listed for the possible smallest angle, so let's try and see which is the smallest. If we look and try and compare angles that are next to one another, angle 2's arm looks a lot more dropped down than angle 3. So angle 2, at the very least, cannot be the smallest, which means we can eliminate choice A. Angle 3 and 4 look a bit closer to one another. Notice how their bottom legs are actually parallel with one another, but the top leg of angle 4 is actually slanted back slightly. So angle 4's imaginary right angle is also going to be tipped back a little bit. We can see then that its bottom leg is dropped down a little bit further from the right angle than in angle 3, which makes angle 3 the smallest angle, and choice C our answer. Here we have a problem from an ADA sample test, which you can find full PAT explanations for on our website. Notice how these angles are very obtuse. This is a case where it's going to be helpful to compare them to reclining chairs and see which ones are laying more flat. First, let's look at our imaginary straight lines. We'll want to place those along the bottom legs of all of our angles. If we look at the answer choices, they all list angle 2 and angle 4 as the smallest 2 angles. But when we look at the problem, angle 4's upper arm just seems a little bit more upright compared to angle 2. So that means it's slightly smaller. And knowing that, we can actually eliminate choices B and C. The comparison between angle 1 and angle 3 is a little bit more challenging, because these angles are both so obtuse. You can kind of tell, however, angle 3 is just a little more reclined than angle 1. So angle 3 is the largest, and choice A is our correct answer. Hopefully, this video gave you a good feel for how to use right angles and straight lines to aid in your comparisons. So, to summarize, just try and keep in mind these simple points moving forward. For acute angles, the larger the angle, the more helpful it will be to compare it to a right angle. For obtuse angles, try comparing them to right angles, or if they're very large, compare them to straight lines. Orient imaginary right angles and straight lines in a way that makes sense for the problem. Put angles into similar or comparable orientations. The bottom leg of a right angle can often be lined up with the bottom leg of the angle in question. And you can use your best judgment to determine which leg will serve the best as that base leg. And when in doubt, align with the longer leg. And finally, try turning your head to view each angle from a similar direction. This can help with small differences in orientation and extreme differences in orientation. And that's all for this video. Try some of these strategies out for yourself, and I'll see you in the next one.